Welcome back. Today, our fifth video of our series Design a Key Value Store. Today we will talk about the consistency. Specifically, we'll talk about the Quorum consensus. And if you didn't watch the previous four videos, I highly recommend to watch them. However, if you watch them but you just need a quick review, I'll make a review quite right now. In this series, we are designing a key value store. We have this question in as a system design interview, and we said that all the time the questions in system design interview are pretty vague, are pretty open-ended, and we should as an interviewee to get the clarifications and make sure that we are getting the right requirements, and we narrow the scope. So we basically design the things that our interviewer want us to design, and after that we'll talk about like a high level design. After that we take deep in specific components, and after that we wrap everything up, and we have this framework that we're using. Today we will talk about we are in the deep dive right now, and we will talk about the consistency. In the next two videos, I guess we will talk about the consistency. Consistency. And I'll just make a quick review. When we have the question, first we ask five. When we have this interview question, first we want to get clarification, so we ask maybe like 5 to 10 questions, but we make sure that it's not less than 5 and it's not more than 10, so we are not wasting time. And I guess 7, it's like from 5 to 8 or 5 to 7, but let's just put 10 if the question was really vague. And from this question, we will know our functional requirements and our non-functional requirements. And after that, I will not go through the questions. You can watch the video because we have video talk about the questions in details. After that, we propose a high-level design. In proposing the high-level design, we talk about the CAP theorem. And when we talked about the CAP theorem, we said that we have availability, partition tolerance as the consistency, and we said the CAP theorem said that it's impossible for any distributed system to guarantee the three things together. We have take two and sacrifice the third one. For example, we have AB system, availability, partition tolerance, while sacrificing the consistency, and we have a BC system, CB system, which is a consistency, partition tolerance, and we sacrificing availability. And we have EC system, we have availability, consistency, and we sacrificing the partition tolerance. And we think that partition tolerance is not something that we can avoid, so EC system is not a real world distributed system application. So we only talk about AB and CB, and we choose AB because our functional requirements requires that we have high availability and acceptable consistency. So this is a keyword just to go with the AB. Maybe your interviewer will ask you for a CP system instead of AB system. There is no design fits all like there is no one design fits all if each design serves specific requirements. What we are doing right now, we just putting the framework and some knowledge of how actually we approach this system design interview, so you will get an idea how you should act in the system design interview. So after we getting the requirements, we propose a high level design, and we said that we talked about the CAP theorem. And when we talk about the deep dive, we talk about that our data is big and we can't store our data in one server, so we use something called partition. We use something called sharding or data partitioning, which will be the key that we have. We put our servers in a hash ring, and we store the key. We go clockwise and store the key in the next server clockwise in a clockwise direction. And by this way we are distributed our data through multiple servers. And when we talked about last video, we talked about replication to support maximum availability, and we said that we should save our key value store in multiple servers to make sure that we have maximum availability, and also we should do replication for data in multiple different data centers to make sure that we have maximum availability. And because right now we have high availability, we will talk about how to manage the consistency and how to make our data as consistent as as possible. And for today, we'll talk about the consistency. We have two things we'll talk about. We'll talk about something called the Quorum consensus, and by this video, we'll talk about the Quorum consensus, and the next video we'll talk about the consistency model. But let's just, this will be for the next video. So let's talk about what is the problem that we are trying to solve. So let's just put and just make it white. Okay, and make it big, and I just want the thickness, I don't want to be thick. Okay, and let's just have our, let's say that we have our servers. Okay, and we have our let's say that the client is let's just give the client a red dot, and the client is maybe trying to make a write request. So, and we will do like write request to send a new key value pair, and and this key value pair will be copied or replicated through the three servers. So let's say that when we save them through these three servers, and maybe this one worked, and this one worked, and this one didn't work. It didn't work. So we have right now the data in these two servers are present, and maybe this data in the third server it's not present, or maybe it's not equal to the other two data. So for this one we have inconsistency. So if we are trying to read anything from this server about the data, if the client tried to reach this server and read the data, it will not read what the client expected. So this is a problem that we're trying to solve, how to solve the consistency issue. So in order to solve this problem, we will talk about something called a Quorum consensus. Let me write it. Okay. It's just a Quorum consensus. Consensus. Okay, let's just put here. I don't want to give it a different color. Okay, so what is a Quorum consensus? Let's just before talk about how it works. So the Quorum consensus is a concept in distributed systems where a certain number of threshold of nodes must agree on a decision or operation for it to be considered a valid or accepted. It is commonly used to achieve the consistency and also to achieve the fault tolerance in the distributed databases and replicated system, because we have a replication now. In Quorum consensus, each node participating in the consensus process have a voting power, and the quorum is defined as a minimum number of votes required to reach a decision or achieve a consensus. The quorum size is typically said to be the majority of the nodes in the system when a consensus operation is initiated, such as updating data or making a decision. Each node casts its vote to operation. The operation is considered successful or accepted if the number of votes received meets or exceeds the quorum size. If the number of votes falls below the quorum, the operation is rejected, and the system may need to take corrective action. Maybe just not just maybe will not accept it. So if we talk about we should talk about three other things in the Quorum consensus. We have something called N, and n will equals the number of replicas that we have. I will say number of replicas replicas that we have, and I want this to be smaller, and just make it like that. Let's delete these two things, and we have the other things. Let's just make this yeah, so and let's just to make the other thing, maybe we have w, and the w is the right quorum size, and we'll talk about what that means. Right, quorum size, and we have no, and we have r, and it's r is the read quorum size. Okay, read quorum size, and these three numbers, and let's just talk about these three numbers. The n is the number of replicas. For example, let's say that we have where is it? Okay, let's say that we have these. So our let's say that we have 3, 4. Let's say that we have these 4, so the n is 4 right now, and the right and w is the right quorum of size. Like right is for what is the size, what how many let's say that how many node replicas we need to make sure to make sure this write operation is accepted. For example, if we have, if w equals 2 and the client make to try to make to make write requests, so we'll send the request for all 4 servers. Okay, if the w is 2, so let's say that we have this something called a coordinator, and the coordinator is acting like a proxy between the client and the servers. So basically this coordinator only wait for request for two nodes to accept that, to make sure that it's this right is the right operation is successful. So that means the right quorum size of 2, and the same thing with the r. Let's say if I make a read request, I need to get a request from 2 servers to make sure that from 2 node replicas to make sure that this read request is successful. And if we looked at it, like I'll just make it make the coordinator, oops, the pin was about to fall, make the coordinator look quite better than that. So let's just add a shape, and okay, and let's say that this is a coordinator, and I want to be white. Coordinator. Okay. And let's support the, can I just take these things and just to make them here, and let's just say that this is the client, another one here, let's put the client, and I just want to make this one be white. Please make it white. Okay, and let's say the client is sending a request to the coordinator. What first of all, I want to be straight, and I want to make it white, and I don't want to be so thick. How to, okay, so basically let's just talk about what's happening here. and the coordinator will send the request to nodes, and it will wait so let's say that if we have w equals to 1, so w equals to 1, that means that the coordinator it's only waits for one response from the node replicas to make sure that um, this write operation is successful or not. So also the same thing, if we have the r is 1, that means the coordinator is waiting for one request from one node to make sure that at least one node to give him a request to make sure that if this read operation is right or not. So let's just take about what's going on. Let's say that the client is making a read request, and let's say that w equals the w equals here equals, for example, 3. Okay, so the client is sending the a write request, and the coordinator receive it, and the coordinator know that the quorum size of the write is 3. So the coordinator, when sending the request, when we try to save the write request to all 4 replicas, the coordinator needs at least 3 requests, 3 successful responses from the servers to make sure this is right request is treated as successful or not. The same in read. If we are accessing maybe like the read is 2, and the client tries to make a read operation, and the column size for the read is 2, so the coordinator is waiting for two requests from the 2 nodes to make sure to make sure that this is operation is successful or not, to consider this operation is successful or not. And if n is the number of the servers, and I want to just make some things to make sure I'm cool. If w plus r, oh, the r is big, what is, if w plus r is bigger than n, if w plus r is bigger than n, that we have a strong consistency. And there is something that we should make sure of while we talk about that, is that talking about the consistency right now is that, for example, if the w is high, let's say the w is 3, that means that we have a high consistency for w. But we have a trade-off. This is trade-offs for the for the latency. It's a trade-off between latency and consistency. When the w is high, that means the coordinator is waits for the slowest third response, or the slowest third successful response, to make sure this is operation is right or not. Otherwise, if let's say the w is 1, that means the latency is super fast, but the consistency has a problem because we only accept for 1. So just make sure that we make a trade-off between the latency or the consistency. So if the w and r is bigger than n, we have strong consistency. Okay, if w if r equals 1 and w equals n, okay, that means we have high right now we're optimizing everything to make fast read. This is for fast read. Okay, if w equals 1 and r equals n, this is for fast write. If w plus r less than or equal n, that means the strong consistency is not guaranteed, but we have a pretty low latency. So this is it. And actually everything has a pros and cons, and maybe when we talk about our interviewer, we could not just reach a specific requirements, maybe we need w plus r should be wait a minute, if w plus r not equals to n, plus r bigger than n. Sorry for this problem. W plus r is bigger than n. Let me w plus r is bigger than n. Sorry for that. So each one has its pros and cons, because when we have high consistency, we will have high low our latency will be higher. So it's a trade-off. If we want a low latency, we should we will that will be we will sacrifice some level of consistency. So everything has its pros and cons, and maybe we will reach to a specific result with our with interviewer, because maybe interviewer maybe prefer w before high consistency, or maybe your interviewer prefer fast read one, w will equals n and the r equals 1, and maybe your interviewers will present the r plus w will be less than or equal n, because maybe we are supporting we want to really care about the latency about this application. It depends actually about what our interviewer wants and what are our your requirements of the system is. And I will say it again, in my opinion, the most important part in the system design interview is the first one. Understanding the problem is the most important one, because if you didn't get this thing right, all the three steps, all of them are you're just screwed. So just make sure that you're getting your requirements right, and based on the requirements you will choose these specific things, what you will choose from them. And that's it for today's video, and hope that you like my video. And if you like my video, make sure to give me a thumbs up, hit the notification bell so you will never miss a video, and see you in future problem. And before you leaving that, 96% of the people that are watching my videos are not subscribers to my channel. So make sure to subscribe, because this helps me to create more content, and this is help our community be bigger and bigger. So yeah, so make sure to subscribe and share the video. Feel free to share the video, and yeah, that's it. See you in future problems.